Hello, welcome to my project for the second semester. Now, up till now, I hadn't found a use for conics that we learned in chapter 4. Now, I have, especially for one shape in particular, the ellipse. That is because the ellipse is the shape of all planets' orbits. For my problem today, we will be finding out the eccentricity of Earth's orbit. Using what we know about ellipses, we can create a graph that will show us the eccentricity of Earth's orbit. First, we know that the Sun is at one focus, and that will be modeled by our clear thumbtack. Next, we know that the edge of Earth's orbit is a perihelion distance away from the Sun. Of course, this value had to be found through research, and I know that it is 91.4 million miles away. Next, we need to make it so that the other edge of our ellipse is an aphelion distance away, which we know is 94.5 million miles away. So, from here, we use what we know about ellipses rather than our solar system. We know that any point on an ellipse is a constant distance away from our foci. This constant distance, in this case, is emulated by the string. So we simply put the pen at the edge of the string and draw our ellipse. Here we go. So this models our Earth's orbit. From here we find our semi-major axis. We know that the major axis is the perihelion added to the aphelion. So we add them together, which is our major axis, and divide by 2 to find our A value. The semi-major axis. We find that this is 92.95. Secondly, we subtract our major axis length, 92.95, from our perihelion to find our C value. This is because our A value is the distance from the center to the outside. Our perihelion is the distance from the outside to the first focus. So we remove the perihelion from our semi-major axis, and we are left only with the value of the distance between the center and our Sun, or our focus. This is our C value. We find this to be 1.55 million miles by subtracting 92.95 and 91.4. So from here, we simply use our formula to find our eccentricity, which is E equals C over A. We plug in our values, and find that our eccentricity equals 0.0167. What I just showed you was a more geometric type of proof. However, we can also show our eccentricity using simple algebra. We know that we need the C value and the A value to find our eccentricity. So, our A value is the distance from the center to the side, and it is found by the average 91.4 and 94.5. By taking the average of these two numbers, we find our A value, which equals 92.95. Now, our C value, which we find by subtracting 92.95 and 91.4, equaling 1.55, which is our C value. So, we use our eccentricity formula, E equals A over C, plug in our two previous values, E equals 92.95 over 1.55, and find our eccentricity once again to be 0.0167. For our last method, we will be using a combination of algebra and technology, our computer to be specific. So, with the values we already know, we will create a formula for the ellipse. So, we have our C value, which is C equals 1.55, and we have our A value, which is 92.95. You will use the formula C squared equals A squared minus B squared to find our B value to plug into the ellipse formula, which is x squared over A squared plus y squared over B squared equals 1. So, we start by plugging in our C value. 1.55 squared equals, and then we plug in our A value, 92.95 squared, minus our variable B squared. We solve this, and we find that B equals 92.94. Now, we plug this into our formula, x squared over A squared, which is 92.95 squared, plus y squared over B squared, which is 92.94 squared. And this equals 1. Now, for all those following along, I would like you to go to the website at www.wolframalpha.com/examples/conicsections.html. Now, once you're here, you'll see an ellipsis section. Go down to eccentricity of an ellipse. Once there, you replace the semi-axes they have in with our semi-axes. 92.95, our A value, and then we put in our B value. For the sake of accuracy, I will put in the lengthened B value I got from my calculator. So it's 92.9393707549. We enter this and find that our eccentricity would round to 0.0167. This is the same as our other two formulas. Thank you for watching.